Hello, everyone. I hope you all are doing good. And every day we are seeing many things happening in the world, whether it is related to technology, whether it is related to war. So, for positiveness and kindness, we'll be talking about technology. AI is also bringing many advances, especially if you have heard about Claude. These people are rapidly progressing and launching new products which are showing their skills in various domains, including cybersecurity, including IT. And I hope in upcoming time, Claude AI is going to bring much more major changes in other domain also. There is a race of AI between GPT, Chat GPT, Google, Perplexity, Claude. So far, what we are seeing that Claude, though it started later, but it has in a position now as a winner of all. And now it has been promoted by many of the YouTubers. Learn Claude co-work. Learn how this Claude gives your AI based products like services. So learn how this Claude is being working before it replaces you. But the point is, okay, it's already built product by Anthropic, and all are just like teaching how it works. Nobody will teach. Can we make our own cloud? No, that's not the deal. The deal is kindly learn how this work. But we are not learning any algorithm, any model to be built from our side. Okay, so far we are the consumers. Okay, we only take the service, whether it is Google, Gmail, WhatsApp, YouTube, Twitter, Instagram, Facebook, and all. If I make a list of the applications, all that means fully reliable on such technologies which are governed by other people. Right now, also I'm taking this class on Google Meet. None of the application is mine. And if someone says you via YouTube is not also there, sir. But everyone is launching course. No, no, no. Courses, I am not at all interested so far. So far, I have been doing live sessions. I every time pick up a research paper. I every time discuss the research paper, algorithm, technique, maths used in the research paper. I show some implementations and demonstrations in front of you, that using those algorithms techniques how results are coming. And I will be continuing that. Okay, my goal is not to teach you what is built by someone else and make you to be what I say, like in Hindi I call as gulam. Okay, like you are just dependent. That's not the case. Anyways, because AI, as per your requirement, you need to define it, not on the basis of other people requirement. You want technology according to your perspective. Okay, you are working in medical, fine. You are good person in medical data understanding, fine. You know about the models related to you working on the images, fine. Now what better you can do in that field rather than relying on others? That is the perspective. That's the reason we explore mini research and come up with an idea. It takes time. Research takes time. Exploring paper takes a time. And many of the people have joined my workshop, attended my workshop. I guess we have already wind up the algorithms. Classification done. You are well aware of CNN based models. You are aware of transformer based models. Now, who is asking for classification in general perspective? Segmentation, we are already done with unit plus plus, attention mechanism along with the unit. Here also all attention and everything, every layer, every CNN based pre-trained models, ResNet, DenseNet, VGG, Inception, Exception, everything I have covered. So classification, segmentation, object detection, YOLO algorithms, done. Most of the papers which I am seeing right now, they are building algorithms for generation. So now if you talk about the idea, what could be the next is the generation part. So I was exploring these papers only. And if you want to work upon this classification or some segmentation, kindly use some technique, technique which reduce your computational capability, some novel idea with justifications. Okay, your idea should be inspiring. Someone should listen and think, yes, this person has done a work and that should be appreciated. And who is going to appreciate your work? Research paper. From where you are going to get the appreciation? YouTubers, no. Research paper, quality general. From there only you are going to get the appreciations. Else you are not going to get the appreciation. So I have been working on projects long time. I have taken a lot of sessions. It's like 3 years now, 3 years, 4 years now. When I will interacting from the people background, I have been working. Now it's 18 years teaching this particular field. 18 years now, but 4 years I'm much more into the AI. But previously I was in computer science engineering. But since this past 4 years I'm in this AI field, data science field, and things changes very rapidly. Projects I was taking a long time, but at that moments when I used to take, it was like data. It was like data exploration, visualization, and simple models. Then later on, deep learning came and things went far. Then generative AI came, things went very far. Gen AI, things went very far, such algorithms came. And now, after that, with RAG and AI agent, we are in a graph like this, in this way, by seeing the work of Claude, which I am talking. Recently, they shared a product related to cyber security. They told us that we have built Mythos. I guess that's the name. It can explore the entire website and all its like files, and it can find a bug in it. Previously, it happened that those people who work in cyber security, they, if they find a bug in these websites and all, na, they are given bounty, thousands of dollars of finding the bug. Now, a AI agent who can explore everything and can find the bug. We are also seeing firing of many people across the globe, big companies. I heard the news Oracle fired 30,000 employees. 12,000 are from India only. Same thing with Amazon. Sometimes it came to hear us that they are also hiring the people. For what? Now, if I talk about the startup and all the company, what they are expecting, a candidate apply for a job. They call them for the interview. They ask, you know what they ask? They ask the basics of machine learning, deep learning, generative AI, some models. For example, BERT, Transformer, their architecture, which I have already taught. So first of all, in this way, they do actions. After that, they switch to Python programming. They switch to Python programming. And they ask the candidate to write code in Python. So if you are preparing for interviews or like that, basics of machine learning, deep learning, generative AI architecture should be known to you, first of all. Then code should be known to you in Python. Don't just like vibe coding we can do every time. No, they will give you some challenging Python programming questions and you need to make it. After that, now they will ask you for deployment. Deployment, okay. Do you know Kubernetes or this AWS, GCP in this way? CI/CD pipeline, that means complete ML pipeline. They are going to talk you about the deployment part. Okay. So for architecture, they take some hint from you that do you have an some idea about ML and all these stuff. Coding, okay. Do you have an idea about the Python? Then they come for the deployment. Actually, they want a person who is entirely skilled in such technologies. So if I talk about Docker, Kubernetes, I guess not everyone is skilled in such server side scripting. What I have learned from my side, yes, Python, architecture development. But if you want to scale up with this part, then you need to find other resources apart from me. Okay. However, at the end of the day, they will say, okay, you know the deployment now? Okay. We can, what we can do is we can hire ChatGPT API Either we can hire Gemini API, either we can hire Claude API. Okay, so we will build some product. Beside that, these people will be working and we'll make some website. Okay, and that is our product launch. Actual game na start from here. Data. Actual game start from here. Those who don't know about data, those who don't know how to pre-process the data, data is the key. Without it, nothing is possible. Data is important. So all the steps of data should be known to you. Because if you don't feed model good food, because data is a food for a model. So if you don't feed good food to the model, obviously model will not get protein and vitamin. And without protein and vitamin, how there will be survival? All the nutrients should be given. Na? So nutrients, you need to filter the data, then it will provide the nutrients to the model. So from here till the deployment part, you have been asked in the interview. Those people who are working on an industry perspective. And academics also we should be knowing. Because coding, architecture development, data, till here every academic person is also been working. Okay, maybe deployment not that much because they need to show the results, plots. So till coding, they can build up. In research paper, this is what we know. All right. And every problem statement do have in AI, you need to think how to solve it as per your perspective, not as per someone else's perspective. Your perspective. For that, you should be good in maths. Also, reasoning. You should be good in reasoning. Also, how to tackle real world. How to tackle real world. And if you are aware of neurons, you are aware of layers, you are aware of input and the output from these things, what we are achieving. If you can able to track the issue, this will come up by only research, reading. And so many past workshops of minds has covered many of the concepts, whether it is mixture of experts, very amazing. Right now also I'm researching more on it. Lottery ticket hypothesis, all these CNN pre-trained transformer, Swain transformer, Max transformer, hybrid, everything done. Our goal was to reduce the computational cost. Now I'm working on tokens or the patches, how it can be reduced to maintain the overhead. That's what I'm researching right now, and I guess one of the week we will come up with a paper also. We are having the people. Okay, fine. Anyways, by keeping all these things into track, and now coming up apart from classification and the segmentation, I thought to talk about generation, image generation. That is what I thought to talk. Let me share my entire screen. I have a research paper also, but before that, I will be talking about some techniques for generation, image generation. All right, now listen to me. Classification, segmentation has been done a lot of times, but generation is something which we haven't touched or least work on that. If you remember, while following up the entire data analytics steps. At one point, I say you data is imbalance. You very well know all the steps. You very well know. From data collection, data pre-processing, cleaning, EDA, exploratory data analysis, consider visualization also. Then data balancing. Well, I told that your data should be first divided into training, validation, let's say testing. After division only you need to balance, and that too only training. Only balance this thing. No need to touch these. Only balance the training part. And how to balance? Sir, we are in a scarcity of images, no sir. From where we are going to bring the images, sir? Mostly you have worked on medical data. Okay, don't consider only the medical data. Any other data also. Any other data also. There is a scarcity of the labels. If you are taking text also, let's say, so like one of the class is more, another class is less. You need to balance it. So we perform oversampling, or we can perform undersampling. Oversampling, let's say, like resample, or you can use SMOT, synthetic minority oversampling technique. Or we can do undersampling, that means reducing majority class numbers, making it equal to the minority class. In oversampling, minority equal to the majority. So the easiest way which I have performed so far is to create the duplicates of minority, making it equal to the majority. That's what I did. So randomly you can duplicate the images, pick up any image, duplicate it, and making it equal to the majority. That is the easiest way. My most of the projects have been done in like that regards. However, I also told you that there are other techniques too, by the help of which we can generate synthetic images. See, if you don't have the real images, then you can generate synthetic images that looks like real. Because now we are available with the deep learning models who can identify the patterns in the data and they can recreate such patterns. So what those algorithms are? JANS, I already took the name of it. Generative Adversarial Network. Autoencoders, variational autoencoders, diffusion model, diffusion models. So, like, how this algorithm came? Are you thinking that can you make an algorithm? Unless and until you don't know the maths, how you can do that? How you can set up an algorithm? So, what kind of maths? Which level of maths you are talking about? Well, neural network require this maths. Y equal to wx plus b. Only this maths happens in neural network. What else? And it's not a hard deal. While training, we calculate the outcome and then we perform back propagation. That means adjustment of the weights parameters. This is what happens in a neural network. Okay, you are having a neuron given as input x, getting as output y. You are having weight, you are having bias, y equal to wx plus b. Okay, and let's say the output is y dash, then you calculate the loss y dash minus y, and then you differentiate loss with respect to the weight or parameter, let's say, and optimize the weights, reduce the loss. This is the procedure in the neural network. Okay, fine. Some people thought that if I need to create the images, let's say, they proposed GANs, generative adversarial network, which is having two component: generator, discriminator, and both are neural network only. Both are neural network. Generator, discriminator, both are neural network. And what planning the author proposed for giants? They told that this is generator neural network. You give noise here, means any random data, and this neural network will create something. This is discriminator, again a neural network. Give real data here, real data here to the discriminator. So it will it will discriminate real from fake, because generator will generate fake data. It will be creating anything from the noise, and this is the real data. So this neural network will separate real from fake, give a feedback to generator also, it will give feedback to itself also, that okay, this is the task we have done. Now, taking the feedback from the discriminator, generator prepare itself. Okay, this time I got failed, now next time I will come with preparation. Again it will create, again discriminator will discriminate, again get a feedback, again it will create, again feedback, again create. So this is a lengthy process. So many epochs it will take, thousands of epochs, let's say, to make generator strong by overcoming its mistakes. Our goal is to make generator strong. And why adversarial? What's the name? Generative adversarial. Adversarial means competition. So there is a competition between two neural network, G and D. Generator say, I will make fake image that will look like real. Discriminator say, okay, come on, do it. I will discriminate real from fake. So both are in competition with each other. It takes long time for the generator to get strong, learning from its mistakes. And once your generator will become good, then it will be generating the fake images. That's one of the architecture proposed by the authors. This Jan is not for text generation. Okay, this is for this is for image generation. There are different types of Jans, cycle Jan, and like so many kinds of Jan models are there for image generation. Now, if you are seeing any architecture for image generation, Maybe like one of the architecture is based upon Jan only. All right. But what happened because of this long training procedure, authors came with another idea, autoencoder. They told that if you want to generate now, we already got success. Encoder, decoder. Encoder, decoder. So you will take neural network again. Two neural network you will take again. Here also you are taking a two neural network. Here also will take two neural network. One neural network, one neural network will do the compression. So here is your data. You give the data, and it will compress. So this is a layer 768, 512. Reduce the number of neuron 256, 128, 64. So it's like this. It's like this. This is how I'm going to create a neural network. Reduce the size of the layers neurons present in it and compress your data features into latent space. This is called as latent space. So I am converting high dimensional data into low dimension. This is what I'm doing by compression. Then next, next. Now I will be reverting the process. 128, 256, 512, 768. Make a neural network which is opposite to the encoder neural network. This is what you need to do. Okay, got it. So from here, I can regenerate the features. This is F, this is F dash. See, I'm not writing F, it will be F dash. Why? See, like, you are compressing and then you are decompressing. Obviously, there will be some loss. So F is not exactly equal to the F dash. There will be some reconstruction loss. This is called as reconstruction loss. Loss. Okay, it happens. Okay, but it will look like similar to the original. It will look similar like original, but there will be some loss will be present. This is autoencoder, where I do keep the details. I will keep the details in a latent space, which is low dimension. So from here and then from here, this is encoder, this is decoder. This is latent space. In a compressed format, I keep here. So there are two options. Are you keeping it in a discrete format or are you keeping in a continuous format? How you're keeping the data here, in a discrete format or continuous format. If it's discrete in nature, then I have a less options. So we keep in a continuous format, continuous distribution of the data, likely to be Gaussian in nature. From this only variational autoencoder came into the picture. They told that they told that autoencoder, we are following that. But let's keep the data in the latent space in Gaussian format. And if the data is kept in a Gaussian format in a latent space, we can perform interpolation and we can connect dots point to point and we can create a new form of data. That's what they said. That's what they said. Also, in variational autoencoder, they introduced reparameterization trick. Reparameterization trick. That is that is sigma x plus nu. This is called as reparameterization trick. Okay. Again, sigma is standard deviation, nu is the mean. Statistics. So if you are having images, then you find the features, core features from the images by applying convolutions, etc. etc. Then you can forward it to the neural network, reduce the number of features, convert them into Gaussian format, follow the reparameterization trick, revert the process. New images will be formed. That's a success. So if I compare Jan with VAE, VAE proved to be better than the Jans, and less number of EPOs are required to create a new images. So if you are in a lag of medical images and you want to create new images, you need to counter your data set. Auto encoders could be one of the option to create. Then came diffusion models. Diffusion models. What happened in diffusion model? They told that okay, you are having data, na? We will add a noise into the data. We will add a noise into the data in training. Then we will remove the noise from the data and get the data again. So this will be new data, new kind of data creation. This is diffusion technique. So if you are having a data, add a noise into it while training, and then remove the noise from it. Again, get the data. This is diffusion model, diffusion technique, and it is proved to be very much better than Jan also and variation autoencoder also. This technique. And there is a obviously obviously a logic behind each and every algorithm, each and every technique. There is a logic. Okay, why we are adding the noise? To add the diversity in the data, to learn more complex patterns, and then pick up the noise from it, recreate the data. So stable diffusion, I think year back or something, it came into the picture. Right now, if you know, there are many models are released by American Chinese that they are capable of creating high quality images, videos also. How? Because of this technique only. They are following such techniques to train a model, creating images. Okay, got it. So I do have a paper. Here is a paper which talks about such phenomena. Okay. Comparative analysis of generative models, enhancing image synthesis with VAE, GANs, and stable diffusion. This is the paper. This paper examines the three major generative modeling frameworks: VAE, generative adversarial networks, stable diffusion models. VAE are effective in learning latent representation. I already told you what is latent representation. Latent representation is a layer in your VAE architecture where you have kept the data in a compressed format, low dimension, that is latent, but frequently yield blurry result. Gens can generate realistic images but faces issue of model collapse. Who is interested to train a model for 10,000 EPO? So VAE are good. Giants are also good, but a model collapse, VAE blurry images, not high quality. Stable diffusion model, which produces high quality images with strong semantic coherence, are demanding in terms of computational resources. So if you are working with diffusion models, then they take some resources. They are the best ones, but computational complexity is high. Additionally, the paper explores how incorporating Dino model and grounded SAM segment anything model with stable diffusion improve image accuracy by utilizing sophisticated segmentation and imputing techniques. So they are now in advanced version of diffusion also using Dino model and SAM model, segment anything model. This is released by Meta, Facebook. Again, I guess these two are Facebook models only, Meta models. Grounding Dino and SAM. Suitable for various applications and highlights areas for further research. Okay, good, good. Further research. Introduction. They are talking about giants, VI, everything. I have already summarized for you. Doesn't matter how I summarized, but I have summarized for you. All the notes are available. I will share with you. You can read it. Read either you can read the paper, either you can read my notes, or either you can listen to me. Whatever be the best option for you. VAE, good at learning patterns, but image blurry. Jan, create realistic images, but problem with mode collapse, model collapse, long training time. Stable diffusion produces high quality and meaningful images. Remember, star. This is the best one, where you are going to add a noise in the data and then denoising the data. Okay, meaningful images, high computation. So paper also shows Dino model and segment anything model. That's what the paper told. So, what is the right model for a different task? Understanding the strength and the weakness, identifying the research areas for them. That is the goal of the authors in this research paper. So, that's why it is important to read the research. We will get a direction which model should be used for our data. What our data, unless and until you don't understand, again, I am saying, if you don't understand the data, then how you are going to decide the algorithm for it? That's important. Okay. So every model should understand the semantics, meaning in the data. It doesn't matter it's a text, it doesn't matter it is image. If you prepare a model who can understand the semantics in the data, then only it's better. Okay, in the recent years, AI models have created more scope for generation, whether it is image, text, speech, whatever. Lot of improvement. These models are now used in many research, computer vision, language processing, medical imaging, everywhere. Some of the popular are VAE, blurry image issue, generative as network, hard to train, high quality image, but hard to train. Stable diffusion, generate images step by step, improving the quality. But they are in a requirement of more time and computational power. Okay, so these are the issues with the existing algorithms. Solution is to improve the performance. Researchers are combining diffusion with advanced tools like grounding Dino, help in detecting the objects in the images. Dino model, Dino model is for object detection. Okay, it's already a pre-trained model, very smart model. If you upload any of the image, it will detect the object in it. I have also took workshop on this Dino also. If you remember, self supervised learning, self supervised learning, so it works on this concept too. Self supervision, if any kind of image, any data comes in front of such model which is not known by them, then they do self analyze, self supervise over it, learn its patterns, and give a name to it ahead. This is self supervision. So there are many techniques: semi supervision, self supervision. This is self supervision. Dino. Grounded SAM helps in accurate image segmentation. Very strong model for segmentation. This is segment anything model, SAM model. Okay, so name itself suggests segment anything. Any object present in an image will be segmented by this model. Any object, I'm not talking about any brain tumor or breast cancer or chest x-ray, no. Anything present in the images will be segmented. So purpose of the paper, compare all these models, strength, weakness, techniques to improve, choose the best model, directions. Okay, fine. Good. VAE is a neural network that can learn from data and generate new data, new images. I already told you. It is used without labels, unsupervised learning. Okay, there is no labeled data, no? Unsupervised learning. We are performing. Two components I already told you. One is encoder, another is decoder. We take the image, compress it in a latent space. Instead of fixed value, it learns mean and the variance. Remember, probability based representation. Remember, variational autoencoder. I told that mean and the variance. This latent space. Hopefully, it's going to keep the data in. I told a Gaussian format. Gaussian format. That's a representation. In the entire statistics, Gaussian is something which is the best one. Okay. So it keep in this format, continuous format, Gaussian format, identify the mean and the variance. Then in the decoder, it takes the latent code, latent representation, that particular way how the data is organized in that particular, then revert the process, reconstruct the original image, generate new data from it. So here is a simple flow. Input image, encoder, latent means mean and the variance, then decoder reconstructed images. Special trick, important. Reparameterization. I already told you, reparameterization. This has a model to learn properly using gradient descent optimization. Reparameterization trick. I already told you. This is again because as it told that mean and the variance. So this is the mean, this is the variance. See, standard deviation variance are same only. Okay, are same only. Because square root of variance is standard deviation. Or variance is standard deviation का square. So if I talk about variance, it's standard deviation only. So organizing this two into an equation format, it's called as reparameterization technique. This has a model to learn properly about the gradient descent optimization. Okay. So advantage: generate new similar data, identify patterns, smooth images can be performed. Limitation: generate data which can be blurry. Struggle with fine details. It may happen. Reconstruction can be issue. Reconstruction loss can be issue. All right. So VAE is good one. Variation autoencoders are good. Probability based generative model, but like they learn compressed representation, generate new data, but may have blurry outputs. So JAN, generative adversarial network, is one of the option introduced by Goodfellow in 2014. Again, the idea is to generate images only. How it works, I already told you. Two neural network are there: generator, discriminator, which works in competition, competing each other. Generator create fake image, discriminator detect the fake image, classify real versus fake. Okay, that's what it do. Both improve over time. The result is realistic image. We want generator to get stronger. There are so many kind of Jan. I already told you. Vanilla Jan is the basic version which I already explained to you. That is vanilla. It's not ice cream flavor. It is the basic version of Jan. There are other types of Jans like conditional Jan, controlled generation. DC Jan uses convolution for better images. Cycle Jan convert one image into another image. Horse to zebra. Style Jan very quality face generation. SR Jan improves image resolution. All these types of Jans are based upon generator and discriminator. But specifically, they do have a purpose like vanilla is basic. Conditional is to generate cat and a dog, let's say controlled generation. DC Jan uses convolution neural network for better images. Cycle Jan is to convert one image to another, from horse to zebra. Let's say example. Style Jan quality face. So if you're talking about face images, if you want to create fake face images, you have to use style gen method for that. Don't use DC gen or cycle gen. Okay, fine. Advantages are okay. Sharp, realistic images can be created, but training unstable. Mode collapse generate similar outputs again and again can be issue. Model collapse, high computation complexity, performance hard to evaluate the performance, can overfit. Okay, these are the major issues, but which is not being shown in VAE. In VAE, they told that images can be blurry, but not such kind of issues. Here, Jan, it will take lot of training. Also, if it is overfitted model, then it's big issue. Mode collapse is one of the major concern here. High computational complexity, all these things. All right, fine. Therefore, therefore, stable diffusion. AI generate high quality detailed images with stable diffusion. Image generation, image editing, image to image conversion, filling missing parts in the images, super resolution, creating high quality images. Stable diffusion is a technique. It improves the older version of VAE, which is creating blurring images and instability in chance. And unstable chance, how as I told you previously, stable diffusion works in two main steps: add noise, then remove noise. This is the game which they are playing. Start with a clean image, add noise to it slowly, step by step. Image becomes pure noise. So you are having a good image, add noise, make it impure. Then reverse the process to get the pure image again. Remove noise step by step. Gradually reconstruct the image from noise. At the end, you are going to get clean, high quality image. So first, add a noise, make it impure. Then remove the noise and make it pure. Sir, what are you talking? This is the algorithm. No? This is the technique. What I am saying. I am saying that only which is applicable. Okay, got it. So autoencoder compress the image, reduces computation, then decompress. Unit remove noise. Main model that remove noise rebuilds the image. Unit we have already studied previously for segmentation. Then there is a clip model also. Convert text prompt into meaning. Guide the image generation. For example, cat on the moon. Model generate matching image. So right now we are performing multimodality. We give text also, we give image also into encoder. This is what we are doing. Give text and image both to the encoder, and then create images using decoder. So this is multimodality. Clip image, clip is based upon that. Just recently we have shared one paper in Q1 general that incorporates this clip part. But we did more in that, which we have some changes. Okay, so but clip was present in it. Okay, got it. Now what happens? These all things we have studied. Grounding dyno, grounding dyno. What actually these are? As I told, object detection, SAM segmentation, stable diffusion, fill or edit the selected parts in an image. If these three are combined, if the approaches three powerful tools, combine three powerful tools to make image editing and generation more accurate and realistic. Together, these smart techniques will make much more better results. So together they can help in smart image editing with a better precision and understanding. So what is inpainting? Inpainting means filling or editing a specific part of an image. This is called as inpainting. Okay. For example, remove a dog or add a tree in an image. Text to prompt. Right now, if you think that how these models are doing, if I give a prompt, add a dog, remove a dog for it, how it is doing? First, it detect that there's a dog present in it. Then it remove that particular part from the image. First, the object based on the text is find out. For that, Dino is used. After detection, segmentation masks, region is selected. That is done by SAM. And then stable diffusion, inpainting. That means that particular region is filled by pixels. Who do stable diffusion? So all these three are used. And we are thinking that okay, some miracle is happening. Some miracle is happening. No. Dino is for object detection. Segmentation is to find those pixels where the object is present. And then it is removed, those pixels are removed, and stable diffusion will fill those pixels by something else. Done. This is what happening. In combination. Okay, so object detection, segmentation, imprinting. Okay, got it. Fine. So combining detection, segmentation, diffusion is performing high accurate and realistic image editing techniques. Okay, got it. That's what I need to talk. All right, all the rest of the concepts as present in the research paper in a very simple way I have mentioned you here with comparative table also. This is comparative table. What is the theme of the models which are used for image generation? Here is some maths related to it. For example, generator will take noise and create fake data. Discriminator classify real and fake. So there is a min-max game between these two. Who is going to win the training? Okay, so min-max. Min means, what is min-max? Min means to minimize the error of generator. Max means to maximize the error of discriminator. If we make our generator strong, means to minimize the error. That's what I want to know. And we want to bring this competition at a particular stage where generator becomes strong than the discriminator. And generator will make realistic images which discriminator can't able to discriminate what is real and fake. That is what happening nowadays. Here is a formula, maths equation. Okay. This is autoencoder formula. X to Z, Z to X cap. That means input to latent representation and latent representation to output autoencoder. This is a mathematical formula x minus x cap ka square. That this is an error actually. Okay, and we need to minimize the reconstruction error. Latent space is deterministic in nature. Variation autoencoder, again I have told you. In variation autoencoder, mean and variance will come into the picture. So latent representation is like Gaussian distribution where these two play the role. This is the mathematical formula for it. And in diffusion model in forward process, you are going to add noise. Reverse process, remove the noise. That's what we need to do. Noising and denoising. In steps, we are going to do. In steps, add the noise and remove the noise. So people, I guess, don't know, but they have heard the name. So diffusion model, diffusion. The diffusion means add the noise and remove the noise. So model learns to predict the noise, generates data by reversing the noise steps. This is the interpretation of diffusion model. Got it. So on the basis of these concepts, research paper, everything what I told you with the images perspective also present in the research paper that I will share with you. All algorithms which I explained is present in the research paper. Okay, got it. It's present in the research paper. Here you can see. So grounding dyno will identify that okay, this is a face. Segment anything will remove the pixels from the face, and stable diffusion will fill it with someone else. What I gave the prompt smiling face. So this image, this girl face will be replaced by smiling. This is what happening at the back end. So combination of dyno, segment anything, stable diffusion. Alright. Above is stable diffusion architecture. This is also stable diffusion architecture where I'm using variational auto decoder, auto encoder and decoder. Okay, and this is GAN, generative adversarial network. This is the noise given to the generator. This is a discriminator separating the real versus fake. I'm having discriminator loss, generator loss. All things are happening in the architecture. I already explained you with the concepts. You can read them. Okay, got it. That's a research paper with the conclusory remark and the difference between all of them. Got it. And if you want to experiment these things, we do have a benchmark dataset called as MED-MNIST. See, we have worked on MNIST dataset previously. It's a benchmark dataset, MNIST. Fashion MNIST, Digit MNIST, but but we do have MED-MNIST also. In MED-MNIST, benchmark dataset, MED-MNIST for biomedical image classification. Standard dataset, 2D, 3D, biomedical image dataset, benchmark dataset, present. See, here it is. Path MNIST, chest MNIST, derma MNIST, oct MNIST, pneumonia, retina, breast, blood, tissue, organ, nodule, fracture, adrena, vessels, synapse, all these images are present. You can pick any of them. It's a bench. You can pick any of them. Okay, got it. Any of the images can be picked. We introduce a MED MNIST, large scale MNIST dataset, including 12 data, 6 datasets. That's what they are saying. Okay, that's what they are saying. All images are pre-processed into 2828 resolution for 2D and 2828 for 3D, corresponding classification label. All these things primary data modalities in biomedical med is performing classification, lightweight 2D 3D images, various scales, 100 to 1 lakh, diverse tasks, everything has been mentioned here. You can read the details. I'll share you the link of medmnist. It's simple, medmnist.com. You'll find it. All right, so all key features are mentioned, biomedical images, every data set, colon, chest, dermatoscope, retina, chest X-ray, fundus, breast ultrasound, blood cell. So if you are working on any of the project, now first try and demonstrate our benchmark and publish the result. Our benchmark is good, so we can show our results on path, 2D, 3D, etc. Other abdominal CT. Then see here they mention ResNet 1850, ResNet 50, everything they have mentioned. All right, and how to work on this? Pip install medMNIST and use it. So far, we are working on some data sets like brain tumor, breast cancer. Here you are available all the data sets in medMNIST. You can try on them. You can publish your work. I have done some coding part. Here it is. Here it is. All right. Let me increase. Now you can see. I took some benchmark data from here only. Okay. So pip install medMNIST. I'm not taking any brain tumor data. I'm not taking any chest X-ray data. I'm not taking any breast cancer data, which I used to do in the previous classes. No. medMNIST. Install it. So all the data set present in medMNIST will be available with me. Okay, got it. After that, I need to apply image generation. So let me take pneumonia data set. Pneumonia MNIST. From medMNIST, import pneumonia MNIST. It's your choice. You can import pneumonia, you can import blood cancer, you can import any other. So many data sets are present here. Okay, here you can see breast MNIST, blood MNIST, tissue MNIST, organ MNIST. All these things are present. I took pneumonia at the first. You can take retina also. It's a good thing to start. I guess you are learning for the first time. Just that. Anyways, I took pneumonia, MNIST. Okay, split the data, training, testing, data splitting because it's already organized. Pneumonia MNST, it's already having training, testing, and the validation data. So let's pick up the training data for training part, and I make variational autoencoder. What I did in variational autoencoder, I am having encoder with convolution 32, convolution 64, then flatten. That means I'm applying convolution over it. Okay, this is what I'm doing in the encoder part. Okay, that is what I'm doing over the encoder part. Then at the latent representation, you need to find nu and sigma. As I already told, no? Mean and the variance should be known. So here mean and the variance are identified. And then revert the process. Unflatten, convolution transpose, revert the process. This is variational autoencoder. Perform feature extraction, then perform reverse of the convolution. Convolution transpose. Okay. Here is reparameterization technique. I already told you mu plus EPS into standard deviation. You can write like this. Write like this. Y equal to nu plus epsilon into sigma. I wrote X, you can replace it with epsilon. This is reparameterization technique or trick they are doing here. Reparameterization technique. Losses are calculated based upon the formula. Binary cross entropy, KL divergence, all these losses are calculated. Training has been performed with 50 EPOs I have given. So this is variation autoencoder simple code. Dataset is also simple. Code is also like I kept in that way. 50 EPOs I trained. Then generator, discriminator, Jan model, generator, discriminator. Two components are two. So this is autoencoder. This is Jan model. Convolution transpose, batch normalization. Convolution transpose, batch normalization. Convolution transpose 10x. So it will take noise. It will take noise. It will create an output. Let me show you some code where I have used MNIST. Okay, here over my Kaggle only. Why I did this thing? Let me show you here only on my Kaggle. Jan. Okay, wait. Let me show you. I'm sharing my entire screen. Just see on my this Kaggle only. It's present. Okay, here it is. Fashion MNIST Jan. Okay, and auto encoder. Auto encoder. Yes, auto encoder, variational auto encoder. Okay, let me talk about variation auto encoder. So first you see this fashion MNST Jan. This is generator which I have created. Simple. What I did, what I did, I performed, I performed a neural network normalization, ReLU, convolution transpose. Then normalization, ReLU, convolution transpose. Then normalization, ReLU, convolution transpose. This is generator. A discriminator, convolution, ReLU, convolution, ReLU, flatten. And the last is dense layer. This is discriminator. There is a concept behind the one which I did. There's a concept. Generator will take, see, listen, your data, MNIST, its the size of the image is 2828. So here also in med MNIST image size is 2828 only. Here also it is 2828. If you see the details, they mentioned the size is in the initial they told 2828 pre-processed into 2828 2D images. Okay, fine. So this fashion MNST is also having 2828. One means grayscale image. This is the batch size. How many images are there? How many images are there actually? Shape. Then normalization of the images happened. After that, I created a architecture in which I introduce a sequential model with a dense layer, normalization, leaky relu layer, reshape, and convolution transpose. Then again, normalization, relu transpose. That is inverse. Why? Because it will create an image by taking a noise. And this is the discrimination part. This will take this will take real data and the data which is created by generator. This is a discriminator. At the end, you are going to classify what is real and fake. So this is discriminator. There is a training, simultaneous training of both. And here you can see, after some epos, you can see some pattern of fashion. This looks like boot. This looks like coat. Same thing is happening here also in the code which I am doing currently. Generator, very simple. Transpose normalization, transpose normalization. If you see, the concept is nearly same. Here also I did the same thing. Here generator normalization transpose. And trying something like that. Discriminator to classify between real and fake. There will be binary classification. So at the end, we are having CMOD function to classify. So there will be giant training. 50 epos again I gave for the giant training. And then last is diffusion model. In diffusion model, you are having a convolution neural network. Along with that, you have a component to add the noise. So I will be performing this operation in steps, and I will be keep on adding the noise. So you are going to get your image, you are having an image, and you are going to add the noise into the image. This is what you need to do. Keep on adding the noise into the image and train it. And the results are as follows. First one is variational autoencoder. All 50 epos completed. Then let me show you. Pneumonia MST after 5 epos. 50 epos actually. First one is variational autoencoder. You can see chest images are likely some pattern has been made. Second is Jan. Here also it is starting making the pattern. This is like scrambled. Diffusion is scrambled. I guess it will take more time to create the image. My architecture is very loose. Very simple architecture I am making for diffusion. That is why you are unable to see the good images. Alright. Anyways, but you got an idea that there is some pattern started building. Here you can see looking like chest. Here also looking like chest. For example, I run for 50 posts. I think I need to run for 200 posts. Then some more pattern will be seen. And depends upon the architecture also what you have made for it. It's also not a hard and fast architectures which I am following at the moment. Very easy for variation autoencoder also or encoder also. So if you see, sir, we are having some doubt in the encoders or how we are making an architecture. Okay, we understood the concept, encoder and the decoder. Encoder means to compress. And how you are compressing? How you are compressing? You are taking an image. How we compress an image? How we extract the features from the image using convolution? Using convolution. So at the encoder part, see what you are applying. convolution 2D, convolution 2D. Okay, that is what you are doing. So if I do have an image, I will pass it to convolution. I will pass it to convolution. I will flatten it. Means convert it into 1D. So image is 2D. I extracted the feature. I extracted the feature. Then I converted it into 1D. Then I added that means not yes, reparameterization trick. I applied it here. That is new plus sigma plus. And then I reverted the process. Instead of convolution, now I am applying transpose convolution, and here I am expecting the image. That is what I am doing. You can see in the architecture. Transpose convolution. So, so apply mu and the sigma. Unflatten your image, apply transpose convolution. That's it. This is the architecture. There is no complexity here. What is the complexity? Nothing. So it look like this. It is looking like this. Image, convolution 32, convolution 64. Okay, convolution 64. Then latent representation. Then again, transpose convolution 64, 32. This is the architecture which I made for variation ordering. For Jan, I made normalization, batch normalization, convolution. Because you know what happened in Jan? You need to create an image from noise. So you know noise will be given to generator. Generator will perform convolution transpose. Why? Because this noise which is 1D will be converted into 2D and all. So normalize, then transpose, normalize, then transpose, normalize, then transpose. So create some image, some 2D structure. Pass it to discriminator. Discriminator will classify between real and fake. It is having again convolution and batch normalization. This is the architecture. This is Jan. And in diffusion, what I did, simple, that's what very, very simple architecture I took. I took convolution layer, convolution layer. This is my architecture. Separately, I created a noise. And I'm going to keep on adding the noise into it. And then I'm going to remove the noise from it. Remove the noise. That means denoise. This is the architecture of diffusion. Got it? Fine. All right. So here are the codes for you in front of you. You can see the codes. I took first pneumonia data set, then I changed the data set to something else. Then I changed the data set to breast MNIST. Everything is same. I kept the algorithm same. Then this is breast MNIST. You can see some patterns. I'm going to get the pattern. Started getting the pattern. These all are fake images. Let me remind you. With diffusion, I'm getting some issues. The point is, it needs to be strong. It's not been easy task to create a diffusion model. Creating fake images never been easy. So right now I switched my concern from classification segmentation to the generation part. Here you can see that some patterns are going to be get with 50 EPOs only. I need to increase the EPOs. I'll share this code to you. Okay, it's available. Then this is blood MNIST. In blood MNIST, here you can see. I hope you got my point. What I'm trying. These images are generated images by Jan VAE. Here you can see. The first one is variation. Second one is Jan. Third one is diffusion. But right now it's so much scrambled. It will take time to organize. Further computational capacity, more strength in the architecture is required to make such diffusion model. But here you can see patterns are built related to the blood. These all are fake images, let me remind you. These are not real images. These are created by the model. If I train more clarity will be seen in the images. So you can try these code, review the concept, check out the research paper, and then you can get back to me. Got it, fine. So I was in a different perspective today to talk not for the classification segmentation. I want to talk about generation. I'll be continuing like that way only. Okay, so our discussion is not limited. Our discussion will go beyond many other things which are been happening in the AI field. Got it. Okay. So you can follow these codes. Kindly check out the research paper. I'll share in the group. I'll share my notes also in the group. I'll share this code also in the group. Please follow them. Okay. And learn and get back to them. Thank you very much for your concern, for your time. All right.